Alright, so the big kind of crucial idea is, well, what is an actual difference equation? Okay? So not only do we want to be comfortable with how to use them, but also basically what are they when you see one come up on the page, what is it trying to tell you? Okay, so again, math is just another language. So it's all about being able to interpret what the difference equation is actually saying to you. So first of all, what is a difference equation? Well, here's a definition for you. It's a rule or a pattern describing how to get the next term from the previous term or terms. Okay? Now, a difference equation, in addition to being a rule or a pattern, it has to include 2 or 3 things. The third is kind of left out sometimes, and it's implied. But it must absolutely include a rule and a starting point. Okay? Now, if you've got a rule, that's lovely, but if you don't know where the sequence starts, it doesn't do you much good, and vice versa. And then kind of the third, it's a good idea, but you won't lose marks generally if you forget it, is a restriction on the term numbers. So if you want T1 to be your first term, you can say, well, where n is greater than 1, or greater than or equal to 1 rather. Or if you want to start with the 0th term, okay, term naught, then where n is greater than or equal to 0. But it definitely has to have a rule and a starting point. Now, whenever you see a difference equation, you may not always kind of write this out, but what you should really be doing in your head is basically thinking or translating the pattern to English. So again, math is a language which isn't often as easily understood as English or whatever your first language is, so it is important to be able to think, what is the difference equation really saying to you with symbols? Okay? So going back, we're going to be using that idea of subscripts, so it's important that you have a good grasp when I say Tn, T sub n, T sub n minus 1, that you know what I'm referencing. So if you are unsure, do watch the subscripts video first. So, first example, all I want you to do is translate it. So tell me, what is the pattern actually saying to you? We'll get to actually using them in another video. So in this one here, we've got Tn is equal to 2 times Tn minus 1, where T1 is equal to 1. Okay? So there's 2 pieces of information. The first is the rule. Okay, so there's my rule. And then the last little bit there is my starting point. Okay, so we do want to be able to describe both the rule and the starting point. So we'll start with the rule. Well, again, if Tn is our current term, our focus term, the current term is 2 times Tn minus 1. Well, that's the term directly before. So to get the next term, I multiply the previous term by 2. That's what this lovely mathematical expression here is saying, is that to get the next term, we multiply the current term by 2. Okay? So the rule, to get the next term, multiply the previous term by 2. Okay. So whatever term I'm looking at, okay, to get term 3, I do 2 times term 2. Okay, so it's always just the next one, and then the start. Okay, what that second bit there says is that the first term is 1. Okay, so it has the value 1. And then just kind of a little disclaimer. It also has a subscript 1. Okay, so it's the first term versus being perhaps the 0th term. Okay. So this third one here is a little bit more involved. So it's again broken up into 2 pieces. The first part is the rule and the second part is the starting point. So Tn is Tn minus 1 over 3 plus 4. Okay? So again, this is our, okay, basically to get the next term, I take the current term. Well, what do I do to it? I divide it by 3, and then I add 4. So this is a mathematical expression to say, well, to get the next term, you take the term that you're looking at, divide it by 3, and then add on 4. So again, my rule is that to get the next term, I'll write it in a little bit shorter form here, less technical. Divide by 3, then add 4. Really important that it happens in that order. Okay, notice that the dividing by 3 is happening before the addition of the 4. Okay? And then the start and to be really kind of persnickety here, the 0th term is 15. Okay, so this is my first term number is not 1, but 0. Okay. Now, on this last one here, I've actually forgotten something. So, this one's a little bit different. This is what's called a second order difference equations. The reason being, it's not just got 2 kind of term references. So this one, it's got Tn and Tn minus 1. Okay, so it talks about the term and the term before it. Whereas this one, it talks about the term before it, and the term before that. So because it's referring to 2 previous terms, we call it a first or second order difference equation, whereas the others are first order difference equations. Okay. So, pick some numbers there, totally arbitrary, they don't really have any significance. But here's my important part, my rule. Okay. So, again, this is a second order difference equation because it's referring to not just the term before, but 2 terms before it. Okay. So what this rule really says is add the previous 2 terms to get the next term. When you're given a first order difference equation, you only need 1 starting point, whereas for a second order difference equation, you do need 2 things to start with. Because, okay, to get term 3, I need to have both term 1 and term 2. Okay, so start first, getting less technical here, the first term is 5, and the second term is 8. Okay. So that's the basic idea of what a difference equation looks like and how to interpret it, because that's often part of the challenge.